The next thing we talk about 555 is its control voltage pin, which is pin number 5. Could be the least used pin in the 555, but an interesting one. Let's see what we can do. So at the moment I got the 555 in the A-stable configuration. I got the 470 ohm raised at, from the positive to the 7, pin number 7, and between the 7 and the 2 I got a 10k raised there, and from pin 2 to the negative rail I got 100 nanofarad capacitor. So it's going to produce around 600 odd hertz. But let's see the waveform when we don't have anything fed into pin number 5. In the datasheet they always ask you to connect that to the ground through a capacitor, but I never do that. But no harm done by doing so. Let's see what the waveform looks like, and see what the threshold voltages are, and see what happens when we feed things into pin number 5. Before that, let's see where this control voltage pin is connected. So it's connected to this input of one of the comparator. So if you look at the VCC and the ground, there is 3 resistors going between those 3. So we discussed that before, that it's a voltage divider. We have VCC divided by 3 at this node, 2 times VCC divided by 3 at this node. So it's directly connected to that node. So we should see at pin number 5 the voltage of 2 times VCC by 3. So at the moment I got this circuit connected to 12 volt supply, and let's see whether that value is correct. Let's see the supply voltage, which is set to 12 volt. Yep, it's 12.1. Let's see the voltage at pin number 5, which is the control input pin. According to our datasheet, it should give us 2 times VCC by 3. So that's 8 volts. That's close enough. Here I got channel 1 connected to the output, the yellow trace, and channel 2 connected to the pin of the capacitor, so that's the blue trace. And if you remember, when we discussed about the two comparator voltages, one is VCC divided by 3, the other one is 2 times VCC divided by 3. So in this case it should be 4 and 8 volts. So as you can see, we don't have anything connected to the control voltage pin. So the capacitor voltage is it's going between 4 volt and 8.3 volts. So that's close enough for our experiment. And the next thing is, what happens if we feed something in to that control voltage pin? So we already got 8 volts there. We measured that. So if we inject a current to pin number 5, the control voltage pin, and extract a current, so that will affect the voltage divider. So that will affect the 2 voltages here. So if we feed in a current here, that will increase these 2 voltages. If we extract a current from pin number 5, it will decrease these voltages, and hence the whole characteristic of the 555 will change. So I got my signal generator configured to give 9 volts, 9 volt output. Let's see what we got there. It's so let's feed that 9 volt output. exactly correct. I got 8.6 volts DC coming out from my function generator. So the voltage at the capacitor, the waveform shifted. It just shifted up. So if I increase the voltage, let's see what we have. So 9.5, so even further increased 11. And as you also you can see that the frequency is getting reduced as well. So that's 11.45, almost 12, almost same as supply voltage. We can't go any further. So frequency has dropped to 313. So if we reduce, okay, now it's 9, back to 8. We can even go further down. So that waveform shifts down, and it shifts down way below the original 2 voltages were, and the frequency has gone up to 930 Hertz. So that's, I'm feeding 4 volts here now. So as you can see, the whole dynamics of the oscillation, it changed based on that. And see, let's see what that actually means. We'll connect a piezo buzzer and see what it sounds like. Okay, you probably hear the sound now. That's at 4 volt. Let's go up. 5, 6, almost 6, 7, 8, 9, 10, 11. So let's see if we can feed something else other than DC. So I got the control voltage disconnected. Let's connect that again. Alright, that's our tone. There's nothing fed into the control voltage. So I'm gonna feed a sine wave, amplitude 6 volt and offset 6, so it's not gonna go below negative, go below 0, and it's just 1 Hertz. So you should clearly hear the modulation. So that's frequency modulation using control voltage pin of the 555 time IC. So that's a sine wave. I can change my signal. That's a square wave. That's a triangular wave. That's a ramp. So yeah, there's quite a few stuff we can do with the control voltage pin. Yeah, great. If you like this video, please click that like button for the YouTube algorithm, and also don't forget to share and subscribe. I'll see you next time.